In this module, we will look at the aircraft's ice and rain protection system. We will start out with a description of the system. Next, we will look at individual components of the system. After the system description, we will look at the controls and indicators that were not covered during the system description. Finally, we will look at the uses of the system. The ice and rain protection system provides the aircraft with an all-weather capability. The ice and rain protection system consists of a de-icing system, an anti-icing system, and a pair of windshield wipers. The aircraft ice protection system uses both pneumatic air and electric heat. Pneumatic air provides ice protection of the outer, center, and inner wing leading edges, the horizontal stabilizer leading edges, as well as the engine air intakes and gas paths. These sections of the aircraft use pneumatic boots, which are inflated in order to break up the ice. There are two types of boots. The first type of boot is a cordwise boot. This type of boot is used on the leading edges and the gas paths of the engine anti-ice system. The second type of boot is the annular boot. It is used for the engine intakes. The annular boot consists of circular tubes which inflate at the engine inlets. Ice is removed by inflating the boot. This slightly changes the shape of the boot, which results in the breaking and separation of the ice. Each boot actually consists of two boots, each with its own air supply. One boot is called boot A, and the other is called boot B. Both chambers alternate their inflation times in order to better separate the ice. When a boot is deflated, it is held to the structure by a Venturi effect. The Venturi effect is created by the bleed air. The operating principle of the boot system is to inflate the boots in sequence. The inflation of the boots is controlled by the associated distribution valve. Seven distribution valves control the air supply to the associated boots. There is one distribution valve for each engine intake and gas path, one for the left outboard wing leading edge, one for the right outboard wing leading edge, one for the left center and inner leading edges, one for the right center and inner leading edges, and one for the horizontal stabilizer leading edge. Electrical power heats the propeller blades, the windshields, probes, static ports, and flight control horns. Two windshield wipers are used to remove rain from the two forward windshields. The controls for the windshield wipers are located on the overhead panel. An ice detector is located under the left wing. The controls and indicators for the ice and rain protection system are located on the overhead panel. In addition to the ice detection light, there is a memo panel on the right side of the flight instruments panel. The engine wing de-icing panel has schematic lines that mimic the general layout of the pneumatic portion of the ice protection system. We will now look at the individual components of the ice and rain protection system. We'll start out with the ice detection system. Icing is detected by an ice evidence probe and an anti-icing advisory system which uses a Rosemont ice detector probe. An ice evidence probe, or IEP, is located outside and below the captain's left side window. The IEP is visible to both pilots and provides a visual indication of ice accretion. The IEP is shaped like an airfoil. It incorporates span-wise ridges to increase its ice accretion efficiency. This probe is not heated. The probe is designed to retain ice until sublimation or melting has occurred and is intended to provide the flight crew with a visual means of determining that other portions of the airframe are either accreting ice or are free of ice. The ice evidence probe can be illuminated so that it is visible at night. The light is controlled by the nav light switch. The anti-icing advisory system uses a Rosemont ice detector probe that is mounted on the underside of the left wing leading edge between the pneumatic boots. The AAS provides the flight crew with a visual and aural alert when ice is accreting on the detector probe. Ice accretion is detected by the Rosemont ultrasonic ice detector probe. This probe is approximately a quarter-inch in diameter and 1 inch long and vibrates along its axis at a frequency of 40 kHz. The ice detector is powered by AC Wild Bus 2. As ice accumulates on the probe, the vibration frequency changes, which results in the illumination of the amber icing light on the ice detect panel on the flight instruments panel. This light may be steady or flashing, depending on the status of the horn anti-icing and airframe de-icing push buttons. In addition, a single chime will sound. The amber icing light will illuminate when 0.5 millimeters of ice have accumulated on the probe. At that point, the Rosemont probe will initiate a heat cycle to remove the accretion and start the ice detection process again. If the icing light extinguishes on its own, it indicates that ice is no longer accumulating. However, flight crews should note that an extinguished icing light does not indicate that the airframe is clear of residual ice. You should note that according to ATR and the manufacturer of the Rosemont probe, the detection system may not reliably detect large supercooled drops that are near freezing, since there may not be enough heat transfer to freeze the large water drops that contact the probe. This would typically occur with freezing drizzle or freezing rain. The engine and airframe anti-ice system uses a combination of pneumatic air and AC electrical power. Pneumatic air is tapped before the high-pressure bleed valve and flows through a pressure-regulating valve called the de-ice valve. There is a de-ice valve on both the left and right side of the aircraft. This valve is a pressure-regulating valve. You should note that due to the plumbing of the pneumatic system, the high-pressure port always provides the air for the system. This air is available regardless of the position of the associated engine bleed air valve. Low-pressure port air cannot be used for de-icing. The de-ice valves are opened by selecting the airframe air bleed push button to the on position. In addition, each de-ice valve can also be opened regardless of the airframe air bleed push button position by selecting the engine push buttons on the engine wing de-icing panel. The de-ice valves modulate open or closed so as to maintain a constant delivery pressure of 20.3 psi. The position of the engine bleed valves does not affect availability of air for the de-ice valves to operate. After the de-ice valves, the pneumatic air travels up to the isolation valves and the engine dual distribution valves. The engine dual distribution valve splits the air supply in two. Each line then feeds air to the air inlet de-icer and the gas path de-icer boot. This last boot is also known as the throat boot. These valves are electrically controlled and pneumatically operated. The gas path system utilizes the inertia of ice contaminants along with an S-shaped duct. This design permits air to flow around the corner of the separator into the engine, whereas the heavier ice particles are ejected overboard. The purpose of the isolation valves is to prevent pneumatic air from going into the wing de-ice system in case of a leak downstream. The isolation valves connect the pneumatic bleed supply from each engine to a common manifold. In turn, this common manifold supplies pneumatic air to the de-ice boots for the airframe de-icing system. This arrangement allows the system to remain operative in the event one engine has failed. The isolation valves are powered by the DC essential bus. The isolation valves will open when the airframe air bleed push button on the engine anti-icing and wing de-icing panel is selected on. Since these valves are pneumatically operated, they will only open if pneumatic air is available. As mentioned previously, Selecting the airframe air bleed push button to on will also open both de-ice valves. The common manifold distributes air to the wing and horizontal stabilizer distribution valves. The operation of the de-icing system is controlled by the airframe push button. The system is selected on when the push button is pressed in. This sends a signal to the multifunction computer to initiate a de-icing cycle. The de-icing cycle is selected by the Mode Select Auto push button. Press the airframe push button to continue. When the Mode Select Auto push button is released out, the de-icing system is operating in the automatic mode. The cycle selection is determined by the two air data computers and both multifunction computers. The Mode Select push button is normally in the released out position. At the start of the cycle, boots A in both engine intakes will inflate. The boots are controlled by the associated multifunction computers. At the end of 5 seconds, these boots deflate. Next, boots B in both engines inflate and remain inflated for 5 seconds. Once again, the boots are controlled by the multifunction computers. After this 5-second period, boots B in both engines deflate. Next, boots A in the outer portion of the wings inflate and remain inflated for 5 seconds. During this period, boots B are deflated. MFC1 controls boots A. After 5 seconds, boots A deflate. Next, boots B in the outer portions of the wing inflate and remain inflated for 5 seconds. Boots A are deflated. MFC2 controls boots B. At the end of the 5-second period, both boots B in the outer portions of the wing deflate. Next, MFC1 then commands boots A in the center and inner portion of the wing to inflate and remain inflated for 5 seconds. Both boots B in the inner portion of the wing are deflated. At the end of 5 seconds, both boots A deflate. Next, MFC2 commands boots B in the center and inner portion of the wing to inflate and remain inflated for 5 seconds. Both boots A in the inner portion of the wing are deflated. At the end of 5 seconds, both boots B deflate. Finally, the boots in the horizontal stabilizer are inflated. MFC1 commands boots A to inflate. They will remain inflated for 5 seconds. During this time, boots B are deflated. At the end of 5 seconds, both boots A in the horizontal stabilizer deflate. Finally, MFC2 commands boots B to inflate and remain inflated for 5 seconds. During this time, boots A are deflated. At the end of 5 seconds, both boots B in the horizontal stabilizer deflate. So far, 40 seconds have elapsed. After the last set of boots have inflated and deflated on the horizontal stabilizer, the system will pause for a certain period of time before repeating the cycle. In the auto position, the boots will be inflated and deflated in a 60 or 180 second cycle, depending on the temperature. If the static air temperature is greater than -20 degrees Celsius, the de-ice cycle is set at 60 seconds. If the static air temperature is less than -20 degrees Celsius, the de-ice cycle is set at 180 seconds. If the de-ice cycle is 60 seconds, the system will dwell for 20 seconds. If the de-ice cycle is 180 seconds, the system will dwell for 140 seconds. During this dwell period, none of the boots will be inflated. At the end of this dwell period, the boot inflation cycle will be repeated. The whole cycle length can be increased by means of the de-ice mode selector push button. This push button is enabled by placing the Mode Select Auto push button in the depressed position. This will illuminate the manual caption in the push button. Notice how the arrow on the control panel points to the de-icing mode select push button. Press the Mode Select Auto push button to continue. The de-ice mode selector push button can be pressed in. This causes the slow caption in the push button to illuminate and the cycle is forced to 180 seconds. If this push button is released out, the cycle is set at 60 seconds. The engine air intake and gas paths can be de-iced independently of the airframe. Engine de-ice can be selected by pressing in the engine push buttons. This automatically opens the associated de-ice valve regardless of the position of the airframe air bleed push button and sends a signal to the multifunction computers to initiate a de-ice cycle. The cycle is the same as previously described, except that only the engine boots are operated. The blue on light illuminates in the push button when it is pressed in. So far, we have discussed the de-icing system. De-icing is the process of removing ice. Anti-icing is the process of preventing ice from forming in the first place. On the ATR 72-500, the propellers and flight control horns are electrically anti-iced. In addition, the probes and windshields are also electrically anti-iced. We'll start out with the anti-icing of the flight control horns. The horns of the ailerons, elevators, and rudder are electrically heated using AC wild electrical power. The left elevator and rudder horns receive 115 volts AC from AC wild bus 1. The right elevator and aileron horns receive power from AC wild bus 2. The horn anti-icing system is controlled by the anti-icing control panel located on the overhead panel. The control panel is powered by the DC emergency bus. Horn anti-icing is controlled by the two push buttons. Each push button is labeled so as to indicate which horns are heated. Electrical power is supplied to the associated horn heaters when a push button is depressed in. When a push button is depressed in, the blue on caption illuminates. It should be noted that horn anti-icing is inhibited when the aircraft is on the ground. When any horn anti-icing push button is selected on, the caption in the icing AOA push button located on the flight instruments panel illuminates green. This is due to the fact that the stall warning angle of attack threshold has been automatically lowered by the selection of horn anti-icing. The green caption serves as a reminder to the crew that the stall warning AOA threshold is now lower. The icing AOA light also serves as a reminder for the crew to set the speed bugs and observe minimum icing speeds. The green icing AOA light can only be extinguished manually by depressing the push button after both horn anti-icing buttons have been selected off. This should only be done after the crew has confirmed that the aircraft is clear of ice. By deselecting horn anti-icing, the stall warning AOA threshold is reset to the values defined for flight in normal conditions. The inner leading edges of the propellers are electrically anti-iced. The heat decreases the adhesion strength of the accreted ice, which then causes ice built up on the propellers to shed by centrifugal effect. Propeller heat is powered by the respective AC wild bus. Heat is supplied by resistors mounted near the surface of the inboard section of the blade leading edges. The heating elements on every other blade on a propeller are electrically connected. Propeller anti-ice is controlled by the two propeller push buttons located on the anti-icing control panel on the overhead panel. When a push button is depressed, electrical power is applied to the propeller heaters on the associated propeller. When a push button is selected on, the on caption illuminates blue. Click on the two propeller heat push buttons to continue. When propeller heat is selected, the propellers will be heated using a cycle similar to the airframe boot inflation cycle. The heating cycle is selected by the Mode Select push button located on the same control panel. When propeller anti-ice is selected, blades 1, 3, and 5 on propeller 1 are heated for 10 seconds. After 10 seconds, heat is removed from these blades and heat is applied to blades 2, 4, and 6 on propeller 1. Heat is applied for 10 seconds. After 10 seconds have elapsed, heat is removed from blades 2, 4, and 6 on propeller 1, and heat is applied to blades 1, 3, and 5 of propeller 2. After 10 seconds, heat is removed from these blades and heat is applied to blades 2, 4, and 6 on propeller 2. Heat is applied for 10 seconds. At the end of the 10-second period, heat is removed and none of the propeller blades are heated. The complete heating cycle will be repeated after a 10-second period. This cycle is called the low power cycle and is used when the temperature is between 0 and -10 degrees Celsius. The propeller heating cycle can be manually controlled by the Anti-Ice Mode Select push button on the anti-icing panel. This push button manually controls the propeller anti-icing cycle when the Mode Select push button on the engine and wing protection panel is in the manual or depressed position. When the Anti-Icing Mode Select push button is in the normal released out position, the low power cycle is selected for the propeller anti-icing. When the push button is pressed in, the propellers will be heated using the high power cycle and the on caption in the push button illuminates blue. The high power cycle heats the propeller blades in the same sequence, except that the heating time is 20 seconds and there is no pause between cycles. The two front windshields are heated to provide anti-icing and defogging. The side windows are heated so as to prevent fogging only. The forward windshields are heated by an electrically heated transparent film that is sandwiched between the two plies of glass. Each windshield heat is powered by the associated AC wild bus. A temperature controller maintains the temperature of the outside ply over 2 degrees Celsius. The controller maintains the inner ply above 21 degrees Celsius to prevent fogging. There are two temperature controllers, one for each window. The side windows are heated by the associated 28-volt DC bus. The heating system consists of small wires embedded between the two plies of glass. The side window temperature is regulated so as to maintain the inner temperature of over 20 degrees Celsius. Window heat is controlled by the windshield heating control panel located on the overhead panel. Two push buttons control the heating of the two forward windshields, and the side windows push button controls the heating of the side windows. When a windshield push button is pressed in, the associated windshield heat is supplied AC power. Forward windshield heat is deactivated by releasing out the associated windshield push button. When the push button is released out, the white off caption illuminates in the push button. The fault light illuminates in the event there is a loss of power to the associated window heat system. This will cause the master caution lights to flash, the anti-icing light illuminates amber on the CAP, and a single chime will sound. The fault light illuminates during an MFC test. The side windows push button controls the heating of both side windows. Side window heat is activated when this push button is pressed in. When selected, the blue on caption illuminates in the push button. Side window heat is deselected by releasing out the push button. The aft portion of the side windows are not heated since the heating element is designed to warm the whole pane. Therefore, ice buildup aft of the heated portion is usually an indication of severe icing and/or freezing rain. AC power is used to electrically heat the captains, first officers, and the standby pitot tubes, the captain's and first officer's alpha probes, and the total air temperature probe. All probes are heated by the associated AC wild bus except for the standby pitot tube and the 3 static ports. The standby pitot tube is heated by AC wild bus 1 and the 115-volt AC standby bus. The captain's and standby static ports are heated by DC bus 1, whereas the first officer's static port heat is powered by DC bus 2. Probe heat is controlled by the probe heating control panel located on the overhead panel. The captain, standby, and the first officer push buttons control the heat to the associated probes. Probe heating is activated when a push button is pressed in. Probe heat is deactivated by releasing out the associated push button. When released out, The off caption illuminates white in the push button. Static port heat is controlled by the associated probe heat push button. For example, the captain's probe heat button activates the captain's static port heat. Fault lights monitor the heating of the associated probes. These lights are located above the control push buttons. When a probe is not heated, the associated light will illuminate amber, a single chime will sound, the master caution lights will flash, and the anti-icing light illuminates on the crew alerting panel. This will occur if there is a fault in the associated heater or if the system is turned off. The control panel displayed here is interactive and you can turn the probe heat on or off. It should be noted that the total air temperature probe heat is automatically inhibited when the aircraft is on the ground, and the condition of the probe is not monitored when the aircraft is on the ground. In addition, the CCAS does not monitor the condition of static port heat when the aircraft is in flight. Two windshield wipers remove rain from the two forward windshields. Each wiper is driven by a 2-speed DC electrical motor. The captain's windshield wiper is powered by the DC Essential bus, and the first officer's windshield wiper motor is powered by DC bus 2. Each windshield wiper is controlled by an associated rotary selector that has 3 positions: off, slow, and fast. These selectors are located on either side of the overhead control panel. When off is selected, the wiper automatically parks. The fast and slow positions control the speed of the associated wiper. Fast will cause the associated windshield wiper to cycle 130 times per minute, whereas the slow position will result in 80 times per minute. It should be noted that there is a speed limit associated with the use of the windshield wipers. Windshield wipers should not be used when the airspeed is above 160 knots. We will now cover some of the controls and indicators that were not covered during the system description. The ice detect panel is located on the captain's side of the flight instruments panel. As discussed earlier, the icing light illuminates when ice accretion is detected by the anti-icing advisory system. The light illuminates steady if accretion is detected, and both horn anti-icing and airframe de-icing are selected on. If either horn anti-icing or airframe de-icing is off, the icing light will flash. The fault light illuminates in the event of an AAS detector fault or a loss of power to the system. This will be accompanied by the flashing master caution lights and the illumination of the anti-icing amber light on the crew alert panel. In addition, a single chime will sound. The icing AOA caption illuminates green in the push button when at least one horn anti-icing push button is selected on. The purpose of this illuminated caption is to remind the crew that the stall alarm threshold has been lowered. The caption can be extinguished only by pressing the push button, provided both horn anti-ice push buttons are selected off. The ice detection system can be tested by means of the push-to-test button located between the two lights. The button should be pressed and held for 3 seconds. During the test, the icing amber light flashes and a single chime will sound. If a fault is detected during this test, the fault light will illuminate. A de-icing light located on the memo panel illuminates blue when the de-icing system is selected to on. This light will flash if the de-icing system is still on 5 minutes after the last detection of ice accretion. As discussed earlier in this module, the engine push buttons control the de-ice valves as well as the two outputs of the associated engine distribution valve. When this push button is pressed, the de-ice valve opens even if the airframe air bleed push button is not selected on. In addition, the MFC is signaled to initiate a de-ice cycle and the on caption illuminates. When the push button is released out, the on caption extinguishes and the associated de-ice valve closes. The fault light illuminates when the associated distribution valve is commanded open, but there is no or low bleed air pressure downstream of the valve, when the associated distribution valve is commanded closed, but pressure still exists downstream of the valve, when the airframe air bleed push button is selected off, and the temperature of the bleed air upstream of the de-ice valve exceeds 230 degrees Celsius, or in the event of an incorrect inflation sequence of boots A and B. The airframe air bleed push button controls the operation of the de-ice valves and the isolation valves. When the push button is selected in, the de-ice and isolation valves will open. When the push button is released out, the de-ice and isolation valves will close and the off caption illuminates. However, engine de-icing can still be accomplished by selecting the engine de-ice push buttons to on, since this will open the associated de-ice valve regardless of the position of the airframe air bleed push button. It should be noted that the airframe de-icing will not be available if the airframe air bleed push button is selected off. The fault caption illuminates amber. The airframe air bleed push button controls the operation of the de-ice valves and the isolation valves. When the push button The fault caption illuminates amber, and the CCAS is activated when the air pressure downstream of the de-ice valves is below 14 psi for more than 10 seconds, or when the air temperature of the bleed air downstream of the de-ice valve exceeds 230 degrees Celsius. The fault light is extinguished when the airframe air bleed push button is selected out. If the fault light illuminates, both master caution lights will flash, the anti-icing light illuminates on the crew alerting panel, and a single chime will sound. The airframe push button controls the A and B outputs of the wing and stabilizer distribution valves. Pressing the airframe push button in will signal the MFC to initiate a de-icing cycle, and the on caption illuminates blue. The boots are deflated when the airframe push button is released out. This is the normal position of this push button. The fault caption illuminates amber, and the CCAS is activated when a distribution valve is commanded closed, but bleed air pressure still exists downstream of the valve, or if a distribution valve is commanded open, but no pressure is sensed downstream of the valve. As discussed earlier, the Mode Select push button controls the operation of the de-icing system. When the push button is released out, the system is operating automatically, and the de-icing mode select push button is inoperative. The released out position is the normal position for this push button. The fault light illuminates amber when there is a failure of the MFC, either 1B or 2B, or if there is an ADC failure. Illumination of the fault light will render the de-icing mode select push button inoperative. The de-icing system incorporates an emergency mode of operation. This mode is selected by the guarded de-icing override push button. The emergency de-ice mode is activated by lifting the guard and pressing the push button. This sets a timing cycle of 60 seconds, the override caption illuminates white, and all the de-icing lights extinguish. The emergency mode is used when a fault light illuminates. The fault light in the de-icing override push button will illuminate amber if there is a failure in both MFC modules associated with the air intake boot control, which would result in an incorrect inflation sequence. Horn anti-ice is controlled by the horn anti-ice push buttons. When a push button is pressed in, the associated horns will be electrically heated. Releasing a push button out will deactivate the heating of the associated horns. When any horn anti-ice is selected, the stall threshold is automatically lowered. The fault light illuminates amber, and the CCAS is activated when one of the horn heaters is not powered when it should be. Propeller heat is selected by the propeller push buttons. When a push button is pressed in, the associated propeller blades are heated. Releasing the push button out deactivates propeller heat. The fault light illuminates when the heating elements in one blade in the associated propeller is not powered. If this happens, a single chime will sound, both master caution lights will flash, and the anti-icing light illuminates on the CAP. Before each flight, and regardless of icing conditions, the crew must select permanent anti-icing on. This is called Level 1. With Level 1 anti-icing, the probe and forward windshield anti-ice are turned on. For takeoff and ground icing conditions, but with flight into non-icing conditions, the prop anti-ice is selected on. Continuous relight must also be selected. Remember that the probes and forward windshield anti-ice are always on regardless of atmospheric conditions. If you'll be operating or you take off in icing conditions, propeller anti-ice, horn anti-ice, side window anti-ice, and engine de-ice must be selected on. This is called Level 2. In addition, continuous relight should also be selected. Once again, remember that the probes and forward windshield anti-ice are always on, regardless of atmospheric conditions. For operation in conditions where ice is accreting, the propeller heat is selected on. In addition, the horns and side window anti-ice are selected on, and engine de-icing and airframe de-icing are also selected on. This is called Level 3. Don't forget that continuous relight should also be selected. Once again, remember that the probes and forward windshield anti-ice are always on, regardless of atmospheric conditions. This concludes the Ice and Rain Protection Module.